All right, I'm gonna work on this review for you guys in preparation for your upcoming quiz. All right, so the first 8 of these problems are graphing sine and cosine, and the other 4 problems are graphing secant and cosecant. All right, so there's 12 problems on this review in total. All right, as always, I want to find all this crucial information to be able to accurately graph this function. Okay. Our amplitude, as always, is going to be the number in front of our sine or cosine function, absolute value of it. So absolute value of 3 is just 3. All right, that's how high or low we're going to go. Period is going to be 2 pi divided by whatever's inside of sine, right? Whatever's in front of that x, right? If there's nothing in front of that x, you assume it's a 1. 2 pi over 1 in this case is just going to be 2 pi. We don't have any reflection here because I don't see a negative, and we don't have any vertical shifting here because I don't see anything that's being added or subtracted to this function. All right. Now on top of this, I want to find some key points, right? So that was another important step in graphing these functions. We need key points, right? 5 key points. 0 is always one of them. The other 3 are going to be a quarter, a half, and 3/4. The last one itself is going to be the period. All right, so at the quarter, halfway, and 3/4 mark, you're going to multiply it by the period. All right, so we get 2 pi times a quarter is going to get 2 pi over 2. 2 pi times a half is going to get you pi, right? The 2's are going to cancel out. And then 2 pi times 3/4, the 2 and the 4 can cross cancel. And then you get 3 pi over 2. All right, so I'm just going to use all this information to graph it on this graph right here. All right, these axes aren't labeled, so I'm going to label them using the 5 key points. I got a 0, pi over 2, a pi, a 3 pi over 2, and a 2 pi. All right. Our amplitude we said is 3, right? So my highest point is going to be at 3. My lowest is going to be at -3. So I can label that as well. Sine, this is a sine function. Sine functions are always going to start in the middle, right? So you're always going to have points only at the top, the middle, or the very bottom. Which is why we use our quarterly intervals, right? Because that's what's going to tell us which of those 3 points we're going to land on, right? Sine is always going to start in the middle at 0. And then at the first quarter, it's going to go up. At the second quarter, at the halfway mark, it's going to go back down to 0. At the 3/4 mark, it's going to go down to -3. And at the full period, it's going to end where you started, all right? So it's going to look something like this if you connect it. All right, that is one cycle. As long as you have the 5 key points, you labeled everything correctly, it's in the correct shape and everything, then you're good. All you have to do from here is continue that shape in both directions. All right, so something like that. And then in this direction, maybe something like that. All right, so as long as you make an effort to match it as closely as possible to the period that you drew, then this is fine. All right, let's do the same thing with the next one. I have a sine of x over 1/2. Amplitude here, I don't see anything in front of my sine function, so I assume it's a 1. My amplitude is just going to be 1. Period is going to be 2 pi over whatever is in front of our x. And this time I have a x over 2. I have a 2 on the bottom. I don't have anything in front, so you assume it's a 1. So really this whole thing right here is going to be what's in front of my x, right? This 1/2. So it's going to be 2 pi divided by 1/2. You're going to want to keep change flip that, right? So we're going to do 2 pi times 2 over 1, which is going to get you 4 pi. All right, so your period is 4 pi. Once again, I don't see any reflection. I don't see any negatives. And I don't see any shifting. All right. Now I want to find my 5 key points. All right, so points, 5 points. First one is always 0. The 3 right after are going to be at 1/4, 1/2, and 3/4. And then I have the period itself, right? Our period here is 4 pi. All right, so at my 1/4 mark, multiply it by 4 pi. The 4's are going to cancel. We just get pi. All right, multiply 4 pi times 1/2. The 4 and the 2 are going to simplify. This is going to become 2 pi. All right, multiply 4 pi times 3/4. The 4's are going to cancel, and then we end up with 3 pi. All right, so 0, pi, 2 pi, 3 pi, and 4 pi are the key points. All right, so I'm going to label my axis. All right, so 0, pi, 2 pi, 3 pi, and 4 pi. This is a blank graph. You can label it however you want. And I'm going to say this is 1 and this is -1. All right, so you can go unit by unit in the boxes. That's fine. Doesn't really matter. I chose to do it this way just that you guys can, it's not super smushed together. All right, and once again, this is a sine function. Sine is always going to start at 0 in the middle. All right, so I'm going to have a point right there at 0. All right, and then the pattern goes, it goes up at the highest, back down to the middle, to the bottom, and then back to the middle. All right, so this is one sine wave, one sine cycle. All right, and then you would just keep it going in both directions. All right, as far as the graph goes, right, or just as long as you at least show that it continues in both directions, so something like that is fine. If you labeled your axes differently, then your graph might look a little different than mine, just as long as your 5 key points are plotted accurately. That's fine. All right, let's try the next one. We have an amplitude of 2, right? So keep in mind, amplitude is always the absolute value of A, and A here is -2. Absolute value of -2 is just 2. All right, so we're going to go at its highest 2 and at its lowest 2 units. Period is going to be 2 pi over whatever's in front of the x, so 2 pi over 2 is going to be pi. Reflection, we do have a reflection here. All right, there's a negative in front of my 2, and then I don't have any vertical shifting. All right. As always, let's find the 5 key points. All right, 0 is always the first one. 1/4, 1/2, and 3/4 are the next, and then we multiply those by our period. And then pi, our period, is the last one. All right, so we get 0, pi over 4, pi over 2, 3 pi over 4 on pi. All right, I can use that information to label the axes. 0, pi over 4, pi over 2, 3 pi over 4, and pi. All right, my amplitude was 2, so I'm going to have a point right here at 2, one at -2. All right, sine, once again, starts in the middle. All right, so I'm going to have, starting from the middle, going to the highest, then back down to the middle, back down to the lowest, and then back up to the middle. All right, so this is in general what a sine curve would look like with our accurate period and amplitude. Keep in mind, in this particular problem, we do have a reflection, so we need to graph that as well. All right, so every point in green that we just plotted, reflect it over the x-axis. So this green at the top, that's at 2, is not going to become a -2, right? Reflect it over the x-axis. At 0, it's going to stay at 0. At -2, bring it up to +2. At 0, it's going to stay at 0. All right, we don't have any shifting, so this itself is going to be the final graph. All right, so it's going to look something like that in blue. All right, and then you can just continue in both directions, right? Once you complete the cycle, right, it's safe to do this, right? All right, so your graph might look something like that. All right. And then the last sine function on this page, right, let's answer the same problems. Our amplitude is going to be whatever's in front of sine, 3, Our period here is going to be 2 pi over whatever's inside of the function with the x, so 2 pi over 3. Doesn't simplify, so you leave that alone. There's no reflection here. I don't see a negative in front of my sine function, and we do have a vertical shift. We're going to go down 1, right, because of that negative 1. All right, as always, let's find our 5 points. All right, 0 is going to be one of them. All right, the next 3 are going to be at 1/4, 1/2, and 3/4. And then the last one's going to be 2 pi over 3, right, the period. All right, so at the 1/4, halfway, and 3/4 mark, I'm going to multiply my period. All right, and then simplify, right? 2 and 4 can simplify. 2 goes away, 4 becomes a 2. We get pi over 3 times 2 is 6. For 2 pi over 3 times 1/2, the 2's cancel, and so we get pi on top of 3 on the bottom. And then for 2 pi over 3 times 3/4, the 3's cancel out, and then the 2 and the 4 simplify. So we end up with pi over 2. All right, and that's enough points that we need. All right, so our first one's going to be at 0, then pi over 6, then pi over 3, pi over 2, and then 2 pi over 3. All right, my amplitude was 3. So I'm going to go at its highest 3 units, at its lowest negative 3 units. All right, and then I'm going to graph one sine cycle. Sine is always going to start in the middle. It's going to go up, down, down, up. All right, so it's going to look something like this. All right, so this is one cycle using my 5 points, my period, and the amplitude. Keep in mind, we do want to shift this down. All right, there was a shift here, so I'm going to take all of these points, shift them down 1 unit. All right, so it's going to look something like that. All right, we don't have any reflections, so I can solidify the line. And then from here, once we have our 5 key points with one cycle, then we can continue the graph going in both directions. All right, so it's going to look maybe something like that. All right, again, as long as you make an effort to match it as closely as possible, that's all I care about. All right, so this is fine for this graph. All right, let's continue. On this page, we have cosine curves. All right, so this first one, all the information that we're looking for is going to be exactly the same as we did for sine, right? So amplitude is going to be 4, whatever's in front of our cosine function. Our period is going to be 2 pi over whatever's inside of the cosine function with the x. 2 pi over 1, which is just 2 pi. I don't see a negative, so there's no reflection and there's no vertical shift. All right. Now your points, your 5 points. First one is always 0. Then it's 1/4, 1/2, and 3/4, and then 2 pi is the last one. All right, so then you just multiply these by your period. And then simplify. 2 and 4 can simplify. So we get pi over 2. 2's cancel out, we get pi. 2 and 4 simplify, we get 3 pi over 2. All right, some of these values you're going to see over and over again. All right, so they get easier to find. All right, so I'm going to plot these on the axes. All right, so I have a 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, my amplitude is 4. The highest that I'm going to go is 4 units. The lowest that I'm going to go is negative 4 units. All right, and then cosine, unlike sine, between these 3 points that I see here, this 4, this 0, and this negative 4, cosine is always going to start at the very top. All right, and then it's going to have the same pattern as sine, right? So you start at the top, but you're still going to go down and then up, and then you should end where you started. All right, so you should get a curve that looks something like this. all right? Since there's no reflections or shift, you can continue this curve in both directions, right? It's going to look something like that. All right, something like that is going to be your cosine curve. All right. And then this next one, my amplitude, once again, is going to be whatever's in front of my cosine. It's going to be absolute value of -2, so 2. My period, there's nothing inside of the cosine with the x, so it's just going to be 2 pi. I do have a reflection, right? There is a negative, and there is no vertical shift. All right, my period is exactly the same as it was in the previous problem, so my 5 points are going to be exactly the same, right? So refer back to that problem and some other problems if you don't know how to find those, right? But I'm just going to plot them, right? 0, pi over 2, pi, 3 pi over 2, and 2 pi are my intervals, right? Since my amplitude is 2, the highest that'll go is 2, the lowest that'll go is -2. All right, and my cosine curve is going to start at the very top, and then the pattern starts. All right, go all the way down, and then go back up. All right, so your curve is going to look something like this, all right, but this isn't our final curve. All right, so that's why we only graph one cycle. All right, so we do one cycle, and then from here, you can reflect. Okay, so 2 is going to go to -2, 0 is going to stay at 0, -2 goes to +2, 0 stays at 0, and this +2 goes to -2. There's no shifting, so we can draw a solid curve. All right, and if that's one cycle, you can complete it in both directions. All right, so it's going to look something like that. All right. All right, this next one, our amplitude. Again, absolute value of A. A here is -3, so the absolute value of -3 is just 3. All right, our period is going to be 2 pi over whatever is inside of our cosine. Since there is an x over 2, treat it like a 1/2, right? So this whole thing is what we're going to put underneath our period. All right, keep change flip. And this is going to get us 4 pi. Reflection, we do have a reflection. And we also have a vertical shift. All right, it's a +1, so we're going to go up 1. All right, so our period is 4 pi. We're going to need 5 points. At all of our quarterly intervals, 0, 4 pi times a quarter, 4 pi times a half, and 4 pi times 3/4, and then 4 pi. All right, 4 pi times a quarter is just pi, 4 pi times a half is 2 pi, 4 pi times 3/4 is 3 pi. All right, so I'm going to label these on this graph. All right, so we have 0, pi, 2 pi, 3 pi, and 4 pi. All right, our amplitude we said was 3, so I'm going to mark a 3 on the top, 3 on the -3 on the bottom. All right, and then we can graph our cosine function. So cosine is going to start at the top. All right, and then our points are going to go down and then back up. All right, so it's going to look something like that. Something like that. We have a reflection and we have a shift. So I'm going to reflect every point in blue that we just plotted, flip it over the x-axis. All right, so just directly across the x-axis. And then we also want to move it up 1, right? We had a shift of up 1, right? So move all these points up. All right, so then I'm going to move this up here, this up here, this one up here, this one up here, and this one up here. All right, so then this is one cosine cycle. All right, and then that accounts for all of our transformations, so I'm going to go ahead and continue it in both directions. All right, so make sure to match it as closely as possible to the wave that you just drew. All right, so it's going to look something like that. And then over here, it's going to look maybe something like that. All right, so just like that. All right, and then our last cosine graph over here, we're going to have an amplitude of 2, right? That's the number in front, a period of just 2 pi, right? There's nothing inside of this cosine that's going to change it, so it's just going to be 2 pi. We have no reflection, and we're going to go down 2 units. All right. Our 5 key points in a 2 pi period is going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right? We need our quarterly increments. All right. We've used this period a bunch, so if you don't know how I got those points, look back at another example. I'm going to label it 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right, and then our amplitude was 2, so I'm going to draw a point right here, up 2, down 2. All right, and then this is a cosine function, so cosine starts at the very top. So I'm going to start at the top, 2, and then your pattern starts. All right, so it's going to look something like that. We're going to go down 2 units, so I'm going to take these points and I'm going to move them down. All right. You don't have to draw these arrows. I'm just drawing it so that it's extra clear what we're doing. And so these are now our, oh, I plotted one wrong. Oh, my bad. Right, so I have a point right there. All right, so then now I can connect these points. And then continue the graph in both directions. All right, so it's going to look something like that. All right. Now on this page is going to be our reciprocal functions, right? So secant and cosecant. All right, so you notice that I didn't write amplitude, period, or reflection and shifting. So you don't have necessarily an amplitude for a secant or cosecant function. You do have a period, and that's going to be the same as its reciprocal, right? So what I'm going to do is I'm going to first draw I'm first going to graph the reciprocal function. And keep in mind the reciprocal of secant is cosine. Right, so I first want to find all the properties of cosine of 3x. And then with this graph, with this function, I can answer my amplitude period. And then if there's any reflections. Right, so my amplitude is going to be 1. I don't see anything inside of cosine. My period is going to be 2 pi over 3, right? That's the number I see inside. All right. Now with that information, we need 5 points. I know 0 is one of them. The others are going to be a 1/4, a half, and 3/4. And then the period itself is going to be the last one. All right, so just multiply your period by 1/4, by a half, and by 3/4. All right, so 2 pi and 1/4. 2 and 4 simplify to 1 and 2. And so I have a pi on top. 3 times 2 on the bottom is 6. All right, for my next one, the 2's cancel. 1 times pi is pi. 3 times 1 is 3. All right, and in this next one, 3's cancel out. 2 and 4 can simplify to 1 and 2. All right, so this is going to get me pi over 2. And then 2 pi over 3 is my last one. All right, this is a blank graph, so you can just go ahead and label them, right? So 0 is going to go right here. Pi over 6 is going to go right here. Pi over 3 is right here. Pi over 2, and then 2 pi over 3. All right, my amplitude was 1, so I'm just going to mark 1 and -1. All right, and the reciprocal of secant we said is cosine, so I'm going to graph a cosine curve, right? Remember that cosine starts at the top, and then that's where your pattern starts, right? At the top, and then you go down, and then back up. So you get something like that. All right, with secant, you want to be a little bit more accurate than if it was just a regular cosine. All right, I want to make sure that I'm following the same pattern throughout, right? Because this cosine curve is only going to help us with our secant curve, right? So this is where the points on the graph matter a little bit more than if I were just sketching the graph of cosine. Right, so now with this graph, with secant, this is going to help us, but this isn't our final answer. All right, so with secant, I first need to draw my asymptotes. Right, everywhere that it crosses the x-axis, you're going to have an asymptote. All right, so as much as can fit on your graph. All right, so just draw a whole bunch. And then once you have your asymptotes in each interval, you're going to have a highest point or a lowest point. Right, and you're going to draw a little U shape everywhere that you see that. Okay, so here I have a lowest point, I'm going to draw a little U down. Here I have a high point, I'm going to draw a point going upwards. Right, making sure to stay within the asymptotes that we drew. All right, so as much as can fit in your graph. All right, and then these in purple are your your secant curves. Right, and then you can erase the blue. All right, I'll leave it partially up just so that you guys can... Whoa, sorry, wait, hang on. Okay, yeah, so I'll leave it partially up just so that you guys can have it for reference. All right, so I'll just erase some little bits of it so that it's a little dotted line. All right, so that's the cosine curve. Right, it's a little dashed line, but you don't need it in your final answer. All right. Now with 3 cosecant of x over 2, right, again, I don't know what this looks like until you graph its reciprocal, and the reciprocal of cosecant is sine. And sine of x over 2, or 3 sine of x over 2 is going to have an amplitude of 3. It's going to have a period of 2 pi over, right, this is going to be a 1/2 right here. Right, you want to keep change flip it, so it's going to be 2 pi times 2, which is 4 pi. All right, and then for my 5 points, it's going to be 0, 4 pi times 1/4, 4 pi times 1/2, and 4 pi times 3/4. And then 4 pi is the last one. All right, so we're going to end up with pi, 2 pi, and 3 pi. All right, so I'm going to label that on the axis. All right, my amplitude was 3, so I'm going to draw a point up at 3, all the way at the bottom at 3. All right, and then this is based on the graph of sine. Sine starts at 0. So I'm going to draw a point there. And then your pattern starts, you're going to go up, down, all the way down, and then back to the middle. So it's going to look something like that. All right, and then I want to continue it in both directions. This is going to look something like that. All right. Since this is cosecant, I want to graph my asymptotes. Keep in mind the asymptotes are going to be wherever you have x-intercepts. All right, and then from there you can graph your little U shapes. They're going to be at the highest and lowest points on your graph. All right, so this in green is your final answer. And then I'll leave the sine curve up there so that you can see it. Now for this one, all right, same thing. We're going to base this off of the graph of its reciprocal, right? So the reciprocal of secant is going to be cosine. So it's going to be 1/5 cosine of x over 4. All right, and we're going to have an amplitude of 1/5. And a period of 2 pi over. This x over 4, we can treat it as a 1/4, and then that is going to go on the bottom. And then we can keep change flip. It's going to be 2 pi times 4, which is going to be 8 pi. All right. And then with this 8 pi, we can find our 5 points. All right. It's going to be at 0, 1/4, 1/2, and 3/4, and then 8 pi. All right. So then at these intervals, we're going to multiply by 8 pi. 8 pi times 1/4 is going to get me 2 pi. 8 pi times 1/2 is going to get me 4 pi. And 8 pi times 3/4 is going to get me 6 pi. All right, so I'm going to go ahead and label these on the graph. So 0. Doesn't really matter. I would skip just to show it's a little bit wider than normal. Does not matter how you label it. Right? I'm choosing to skip it for the sake of this example. All right, but you could have still done one box as normal. And then 1/5 as our amplitude. I'm not going to go 1/5 in this particular box. This axis is unlabeled, so I'm just going to label that 1/5 and negative 1/5. Right, this is based on cosine, and cosine is at its highest at the beginning, and then goes down to the middle, and then goes down to the lowest, goes back to the middle, and then goes back up. All right, so this right here is one cosine curve, one cosine cycle. All right, so it's going to look something like that, and you can keep that pattern going in both directions. All right. Now with this, we can draw our asymptotes. I'll do it in green. Everywhere that it crosses the x-axis, you're going to have an asymptote. All right, so you're going to have something like that. All right, and then in each of these intervals, you're going to have a highest point, a lowest point. You can sketch the curve using all this information now. So then what I'm drawing in green is going to be your final answer. So something like that. All right. And then the last one here is going to be number 12. All right. Once again, it's a reciprocal function, so I'm going to want to graph the its reciprocal. It's going to be 2 sine of 8x. All right, we have an amplitude of 2, a period of 2 pi over 8, which is pi over 4, and then we need 5 points. So 0, 1/4, 1/2, and 3/4 times our period, so times pi over 4, and then pi over 4 is going to be my last one. All right, so then this is going to get us pi over 16. Pi over 8 is the halfway mark, and then 3 pi over 16. All right, I'm going to label that on the graph. So I have a 0, pi over 16, pi over 8, 3 pi over 16, and pi over 4. All right. And now my amplitude is 2. Let me label that on the graph. 2 and negative 2. All right, this is based on the graph for sine. Sine is always going to start in the middle at 0. All right, and then you're going to go up, down, down, and then up. All right, so this is what one sine curve looks like. All right, and then you can just keep that pattern going in both directions. All right, being as accurate as possible. All right, and then from here we can graph our cosecant. curve, right? Keep in mind we need asymptotes everywhere that we hit the x-axis. Right, so as many as you can fit on your graph. All right, and then in each interval, draw your little parabola shape. All right, and then what I'm drawing in green is your final answer. All right, this is your graph. All right, and that's your review. It's going to cover everything that you're going to see on your quiz, right? So as long as you know how to get all of your crucial information, if you know how to get the amplitude, the period, and all that, you should be able to graph it. The quiz is still in the works, so it might be all graphs, or it might be some questions we might just ask. Find the amplitude, find the period, all right? But it's nothing that if you understood this lesson that you shouldn't be able to do, right? So it's everything that's completely fair, all right?